In this video, we'll be looking at how to find the solution of the interception point of two linear curves. As a graphical explanation, if we look at this graph here, we've got y of x and f of x. F of x has got a negative gradient, y of x has got a positive gradient, they happen to intersect. How do we find these points? The points that they intersect is this point here, this is yp, this is xp, and so we'll just be going over how exactly to solve two equations to find these points. The best way to do it is to go through an example. So if we start with example 1, find the interception point of y equals 3x add 5 and y equals minus 5x add 7. So if we notice something here, they both have two terms in common, that is y and x, but they both have y equals. If they both equal y, then they both equal each other, such that y equals 3x add 5, which also equals minus 5x add 7. So we can focus on the point that 3x add 5 is equal to minus 5x add 7, and then we can rearrange. So if we get if we add 5x to both sides, we get 8x add 5 is equal to 7. 8x is equal to 2 because we're minusing 5 from both sides, and we have x is equal to 1/4. So to get the y value, we have y is equal to 3x add 5, and x is 1/4, so y is equal to 3, 1/4 add 5. So that's 5.75 because it's 3/4. And so if you want to draw this out, if you want to sketch it out, you roughly have something that looks like this, where x is 1/4 and y is 5.75. Obviously, you can make the sketch a lot more detailed by including, the y-intercepts. So you'd have 5 here, you'd have 7 here, and the x-intercept here, which I won't work out, but you can do that. But as a quick sketch, that's kind of what we're solving for would look like. So taking another example very similar, you can pause the video, work this out, and then come back to the video. So like we did before, both equal y, so we can equal them to each other. So 10x add 1 is equal to minus x add 25. So we can add x to both sides, therefore 11x add 1 is equal to 25. So 11x minusing 1 from both sides is equal to 24. X is equal to 24 over 11, and y is equal to minus x add 25 from this equation here. So y is equal to minus 24 over 11 add 25. If we plug this into our calculator, minus 24 over 11 add 25, we get y is equal to 251 over 11. And so the coordinates of interception are 24 over 11 and 251 over 11. So for example 3, it might appear more complicated because the curves aren't in the traditional form of y equals mx plus c. But that's okay because the approach is similar. So we want to get both of these curves either purely in terms of y or purely in terms of x. So we have 3x add 4y is equal to 20, and 2x minus 2y is equal to 4. If we notice, if we times this whole equation by 2, we're going to get 4y here. So we'd get 4x minus 4y is equal to 8. And just rewriting this equation here, we have 3x add 4, y is equal to 20. If we add these two equations together, which we can do, minus 4y add 4y is equal to 0, and these two terms can't cancel, and then we get an equation only in terms of x. So we would get 7x add 0y is equal to 28, and therefore x is equal to 28 over 7, which is equal to 4. And so that's how we can nicely work out the value of x. Then we can sub this back into either this equation or this equation to work out the value of y. So we have 2x minus 2y is equal to 4. 2x, which is 4, minus 2y is equal to 4. So 8 minus 2y is equal to 4, where if we minus 4 from both sides, we have 4 minus 2y equals 0. 4 is equal to 2y, and y is equal to 2. And therefore the intercept, not the intercept, yeah, the intercept of the two lines, my bad, is equal to, what do we get? We got 4 for x and 4, 2. So that's the generic formula or the generic method of calculating the intercept of two linear curves.